All right, John, thank you so much for being here with me today. Can you please talk to me about the company you created, actual AI, and the original catalyst, pain point, or opportunity that you saw for it in the marketplace, please?
Yeah, sure. When we started Actual AI back in January 2024, and I was coding to begin with before I even hired, before I even got my CTO. There was only Copilot. There was only GitHub Copilot to do kind of line completions, and that was the extent of AI-powered software development. But there was a huge opportunity because for the first time you could process what was coming into code bases with AI. And what I saw as an opportunity to revolutionize the way that we did engineering management. So there's kind of a whole tier of engineering management companies that came on, like Jellyfish and Uplevel, in the previous generation of companies that really had to process that data in a CPU bound way without inference. So you're looking at metrics, things like mean time to ticket resolution, and that kind of metric can tell you one thing about an organization, but be able to step into the world of inference means you can understand so much more. And at AWS, when I was writing a weekly business review and I had to report on the very particular things that had happened in the team over time, I realized that inference could completely automate all of that. And there was a massive opportunity to do engineering management with a tool. Actually, I has evolved a lot over time. So, midway through 2024, we had Cursor, and that was a revolution. By May 2025, we had Claude Code, and that was a revolution. At the end of 2025, I think, every advanced software engineering team in the world realized that it was fundamentally changed. And for the first time, we had models that were sophisticated enough to reliably produce good code. And so, around Q3 last year, we worked out that we needed to pivot the company into something that could help companies adopt a completely new software development lifecycle. So not giving away this capability that we had to look at progress and velocity and AI usage, but adding the capability to help companies govern the way that their agents were building code. And the really big problem that we found, because we had all this exposure to code, we've been doing code analysis for 2 years, is that coding agents were great on greenfield projects. In fact, if you connect in the CLIs from Vercel and Supabase and GitHub, you can do amazing things like straight up in hours. You can create whole new applications that are incredibly sophisticated with data models in the database and beautiful software. But if you are looking at a code base that's over 2 years or 3 years old, that's had over 15 people touch it, that's had hundreds of decisions made, then it becomes really hard for agents to write good code that matches the decisions that have been made, and they burn a ton of tokens. And when we were experimenting with that, we found the highest point of leverage was actually architectural context. And actually, the concept within that we drilled into was this concept of architecture decision records, which is an old concept. Yeah, teams have used this in documentation for a long time, and hence models have been trained on ADRs. And if you can give agents ADRs, they can code cheaper, better, faster, but more importantly, they can actually build good code on larger code bases.
So you said your mission is migrating every software company to AI native development. What is the fundamental difference between a company using AI tools and a true AI native software organization?
Yeah, I mean, there's a whole progression that we see companies go through. And some companies, have their head in the sand. Some are using their, enterprise agreements with Microsoft to access Copilot, which is almost equivalent. Um, some have been sold licenses by OpenAI or Anthropic and now have Codex or Claude Code on every desktop of every software developer. But that's really just absolutely the ground level of being able to use AI in the software development process. What advanced companies are doing is completely changing the software development lifecycle, and they think about all the stages of that cycle. They think about planning and design and architecture and building tests before writing code that's generated, and then review and deployment and continual improvement of that whole process. So like the next stage that we see companies go into is they have things like shared skills libraries that they have all of their developers install in Claude Code or in Codex so that you can run particular skills at different stages of the software development lifecycle when you're either reviewing code or deploying code or initially planning. You can see some of those publicly, like Matt Pocock's Grill Me skill, or Gary Tan's G-Stack engineering manager skill. Those are the kind of skills that organizations tend to build into shared skill repositories early. But where they can go from there is actually building fully automated software development pipelines, which is what we like to call a software factory.
So, how do engineering leaders prevent code bloat? Because AI agents make it so easy to generate a lot of unnecessary code. How do you think about that? Because I talked to another startup, a couple startups are trying to tackle this. What are your
Yeah.
thoughts on this?
Yeah. I mean, for us, everything comes back to context. Um, you know, it's really easy to generate a ton of code with agents. Um, One of the biggest forms of code bloat is additional layers of conflicting architecture where you haven't necessarily made the decision. And so it's not choosing the same architectural approach each time. So, by having the right architectural context, you can have a much slimmer, more efficient application. Also, by making those decisions deliberately, rather than just going with kind of what the agent decides is best practice, by making architectural decisions deliberately, you end up with an application that's much more suited to your particular use case and hence can be much thinner, can be much lighter, can be much more efficient. So it really comes back to, to context engineering for us. And that's really the tool that we build as a governance platform for context engineering for coding agents.
In the most simple way possible, from A to Z, what problem does your company solve?
Yeah, it's efficiently building code with coding agents on large code bases. So CTOs are having to have a hard conversation with CFOs right now. A company we were talking to recently, they have 130 developers. That probably means they've got about 40 million in headcount costs against those developers. They're just heading through $1 million in token spend per year. That's their run rate on tokens. But it would be unsurprising for them and for us if they ended up at about 10 million a year. Because if that's only a quarter of their headcount, but they're getting double the productivity out of their developers, then it makes complete sense. So they have the problem of just token spend. How do you make that more efficient? There's plenty of arguments to say that token spend is going to go down over time because models will get cheaper or we'll get better models. There's lots to say also that token usage will go up. So maybe there's an equilibrium there, and people are always going to justify spending, 10 or 20% of their headcount on token costs from here on out. So our tool on average saves teams between 10 and 40% of their token costs because context can actually reduce the number of research cycles an agent has to do before it writes code. So that's one of the big problems we solve for CTOs having their conversation with CFOs about this new budget they have to have for a token spend for coding agents. The other one is really this kind of gap that engineering leaders, VPs of engineering, CTOs know that they need to have their company get to fully automated pipelines, to software factories, because that's how they keep ahead of their competition. That's ultimately where everyone knows we're going, is bringing the software developer up one level of abstraction. So the designer is building the design system so that the agents can build components, so that the software engineer is creating architectural rules so that the agent can make architectural decisions. But to get there, you need to do a ton of context engineering. You need to do a ton of configuration around that software factory. We work really closely with an open source software factory team called Gas City, and they have an incredible setup internally. Obviously, they use the factory to build the factory, but it requires a lot of context engineering. So when a company decides they want to build this software factory, they can run 24/7. They can put issues into that will generate code overnight, where they have their software developers stepping up one level of abstraction. We can help them do the context engineering configuration required to build that setup. And they still own their own pipeline. They can still build on an open source software factory, but they can use our governance platform to get there in, 6 weeks instead of 6 months.
So, some CTOs are still skeptical about AI coding tools. What is the main reason senior engineer leaders resist adopting these workflows, and what do you say to them to try to open their eyes?
Yeah, it's usually about evidence. they usually have tried out a tool. They're very practical. Like a CTO wants to get on the tools. They don't get time to get on the tools much anymore, but they want to get on the tools. So what they will have done is they will have pulled up one of their big code bases, and they know that there's all of these really great ways you can use Claude Code or Codex on new code bases, and they will have experienced that. That's usually not their skepticism. Their skepticism is to say that, okay, with this sophisticated code base with important compliance requirements, is Claude Code or Codex going to perform? And that's where it usually fails. And that's usually where their skepticism comes from. It's either they've tried it or one of their principal engineers has tried Claude Code on one of their big, sophisticated, mission critical code bases. And that's really where it falls down. And what I can tell them is that we have proof that with proper architectural context engineering, you can actually get great code out of coding agents on large code bases, because the coding agent doesn't have to research the code base every time that you give it an issue. And because you can embed the decisions that are important to you at the governance layer with optimized ADRs. So, it really just comes down then to a pilot. And we've got a bunch of demos on our website, like on demos.actual.ai, that show open source code bases where we're executing issues with and without ADRs to really show the difference, in the number of dead ends that the agent goes down and the kind of token spend. And so all we're doing, going to those leaders is saying, can we build you one of those demos? Can we just take your sophisticated code base and create exactly what we've created with those open source code bases, which is a comparison of using ADRs versus not using ADRs?
So please correct me if I'm incorrect. But are you kind of like an efficiency and context orchestration layer?
We think of ourselves as a governance platform. We think of ourselves as a software factory infrastructure, or infrastructure for coding agents. Um, we do context engineering, which some people consider a dev tool, but we also give visibility over architectural changes and progress within the code base because of our management agent. So we're really the complete solution. We're the complete product if a CTO wants visibility over AI being used in their organization, as well as delivering on the promise of the acceleration. And for that, you really need context engineering.
Can you just break it down like software factories? And I've
Yeah,
heard this before. Like, can you just explain?
yeah,
Is that sort of exist now? Will it exist in the future? Can you just explain like where we are now, where we were a year ago, and what do
yeah.
you envision, please?
It absolutely exists now. But the harsh reality right now is that it takes a lot of time to build a software factory. You need one software factory setup per code base. So there's a lot of configuration you do per code base with a software factory. You can have shared infrastructure, but right now, the only way to build what we consider a true software factory, which is it runs 24/7 and you can give it a certain type of issue and it will come back with correct code changes, unassisted, is to do a lot of configuration. So the way that we think about a software factory is um, right now, we have software factories running to build our code as well. We don't give all of our issues to software factories. Some issues, one of my developers will take and will go and execute with Claude Code, working with Claude Code. But there's a lot of issues now where we can just feed them to the software factory and it will make the correct change and come back with a PR and we can accept it. And this is the kind of thing that Devon was originally promising, and Devon really fell down. It started getting, better early, maybe early mid 2025, but it still never really delivered on the promise of the end to end, high level ticket delivery, like feature delivery. It's really hard to get that performance out of Devon. So what we see as necessary when you are building a software factory that you want to deliver that kind of end to end pipeline where you can take an issue and deliver a code change is configuration that takes into account all of the things you do across these, 6 to 8 categories that you think about in the software development lifecycle. So often now you still have to do planning with a software factory. You have to break down an issue. And the reason is not that the software factory can't do it. It's that when you give an issue to a factory, you usually haven't thought about all the decisions that you need to make as a developer or product manager or person who wants to guide the factory. And that the agent can go through a decision making process with you where it extracts all the decisions that you need to make before it can start writing code. So that's one part of a factory, is you've got a planning process. But I could go on and on about factories, but you've got to have all of these other configurations for all of these other stages worked out between design and architecture and test-driven development and building, writing the code or generating code, and then review, and then deployment of that code, and then continual improvement. And as another example, one of the teams we work with, in the review stage, they have 30 agent processes boot up in parallel around every PR that comes in, 30 in parallel. And then it takes all of those reviews and brings them back together, and then alters the code automatically in that process. But it's important to understand that code bases right now, at least, they have different requirements at each of these stages. So you just have to do a lot of configuration against these stages to make it work. So you've got to go all in. You've got to really put some cash down to decide that you're going to build a factory around a code base. It's got to be worth it for that code base. And so, we run the Software Factory Intensive, which is a 2-day workshop to help companies get there, to train their developers on how to build with a specific open source framework to do that. We also run a software factory pilot where we can take them through 6 weeks of building a software factory around a particular project. Those are not our core product, but we do that because we know that once people understand the power of software factories, they understand why they need a governance platform so they can run 100 software factories with 100 code bases.
Please, I mean, I'm not an expert, I mean, I don't profess to be, but just please help me out. Do you think that agents will eventually become their own software factories at a certain point, and that they'll be like managing other agents, or how do you think about that? Just
Yeah,
wondering.
I don't think we're getting rid of developers, but I think developers' roles have to evolve. And, we think that developers need to step up one level of abstraction. It could be they end up stepping up another level of abstraction. But humans are the interface to the world. And there's a whole range of decisions that need to be made, and also configurations that need to be evolved over time, depending on the requirements of the world that require people. So, you know, can you say to an agent, go make money for me on the stock market?
Well, I mean, I always
Maybe.
laugh about that, right? It's like, tell me what stock to buy. I mean, it augments people, right?
Yeah.
So it's like, it just like it's like leverage. And
Right.
so like I think about like, like eventually, I mean, are you going to have a developer and they're going to have agents below them that administer agent? I mean, how do you think about that? And then that's
So,
kind of the factory. Am I wrong? I mean, in like 5 years from now or something.
well, today, what a factory is with most open source frameworks is agents managing agents. That's today. Like, to have an effective software factory, so Gas City is one of the frameworks we use. Gas City is the evolution of what was originally Gas Town, built by Steve Yagi. Then there was an enterprise version built of that called Gas City. It has like this concept of a mayor, which is an agent managing agents, and you will definitely have agents managing agents, etc., etc. But I think the interesting thing about software development is that as we evolve these concepts, as models get better, the definition of what a software company is evolves. The velocity that a software company needs to deliver at evolves. We're getting to the point right now where you need to have live software. Literally, you can put a requirement in today and you can have your software, the new software, deploy with that new feature or change or bug fix today in hours. That's living software, where you've fully automated your code review processes and your testing processes so that you can have reliable software evolve rapidly. And that's just how, we talked about daily releases a long time ago in software development, but this is hourly releases. This is how fast can you get to live. That's the evolution of a software company. And as we kind of evolve these more and more sophisticated ways to write code, companies will need to keep evolving. We'll need to keep innovating. That's just the rule with software companies. They kind of have a lot of leverage on innovation, and they all keep up with each other by having humans insert into the process so the process can keep evolving.
When AI agents write code around the clock, like you're talking about how software companies are living, right? Where does the new bottleneck in software engineering move to?
We went through this evolution with infrastructure where you had a whole bunch of systems administrators like manually managing servers. And we kind of went through this concept of cattle, not pets, which is instead of having pet servers that you named and you configured personally and you logged into, you had cattle, which is you did infrastructure as code, and you had ways to deploy at scale where you weren't thinking about individual hardware. You had this bank of hardware, and you deployed this kind of abstracted version of your infrastructure on that bank of hardware at scale. And I think that's what we're going through with software is we're working at the next layer up of abstraction. We're configuring, wait, sorry, we're configuring. We're configuring the software factory rather than writing the software itself. So I think like the bottleneck now for innovative companies is how fast can you evolve your software factory? It's how well can you write that configuration? Can you configure that engine? And it's really not even about what velocity you're hitting right now. It's what acceleration you're hitting right now. It's a whole other derivative. If you're not accelerating right now, you're losing.
So you host selective high trust dinners in people's homes for Seattle CTOs and VPs of engineering. What's the top of the mind for all of you
Yeah.
at these meetings?
I mean, we started these in New York with Adam Saar. They're brilliant. I think like we run the biggest DevTools event in Seattle, which is AI Tinkerers DevTools track. So we manage the DevTools track for AI Tinkerers here, and that's fantastic. We get 300 registrations a month, and we get 160 people come along. That's brilliant at to kind of bring a lot of people together. And we have 6 speakers there. We have amazing discussions. But what happens when you bring people together in a setting of like 12 to 16 people is you can have one discussion. You can bring together a very particular slice of people, like just VPs of engineering who have organizations of over 50 developers who are in non-software companies managing that software organization within that non-software company. Like that kind of slice means that set of people has insights to share with each other that are hard to find elsewhere. They can kind of share relevant insights, to each other at a much in a much more meaningful way. And so those dinners are really about bringing together really select sets of people so that they can share insights. We might have a speaker or we might not, but it's just the people in the room, and bringing people into someone's home. Everyone knows that everyone there is trusted. Someone trusted them to come into their home. That just makes a big change in the atmosphere. I've been to tons of tech dinners at restaurants and other places, and they're fun, but I think there's nothing like having it in someone's home for actually hearing real brutal honesty and making friends. So that's great.
So how does a company like Microsoft defend GitHub Copilot and when nimbler startups are capturing the hearts of developers? Is it possible for these large companies to like sort of keep up, or is it just what do you think?
Yeah, I mean, Satya's smarter than I am, probably. I think making the OpenAI acquisition, or buying into OpenAI, hosting their models onto their cloud was an excellent move. It was probably the only way they stayed relevant. I think Copilot itself has a lot of challenges in terms of the developer ecosystem. I think they've thought more about rebranding Copilot across non-coding activities, and that might be a successful strategy because they have the leverage of the Office ecosystem, etc. Um, VS Code was such a brilliant acquisition. I would guess they're going to try and replicate that success, as was GitHub, like brilliant acquisition by Microsoft, right? So, I would guess they will look for winners and make an acquisition to kind of win back developer hearts and minds. I think there is space for more harnesses. We see this kind of latent attraction to open code because people can use a range of open source models and kind of decide that they want to use a router and reduce their spend or use particular models for certain reasons. So I think there's room in the market for more than Codex and Claude Code. So that's how I would expect that they would win. I think the way that Amazon wins, for instance, is just providing Bedrock as an amazing service. If you can give people inference within their VPC at a good price reliably, that is going to be really powerful for AWS. And I think Kiro is a great solution for AWS customers, but they're also really focusing on on their inference services, which is the correct approach.
Why is it that when I talk to so many developers, the overwhelming majority have moved to open source? They don't really use um why is I mean obviously it's a financial reason, but like why do you think that like you talked about you can customize your weights and stuff. What do you think about that?
Yeah, we're not seeing that yet. There are a certain set of developers who are going to open source, but if you look in our surveys, we run in-person surveys at the event, so we always get 100 responses to the surveys at the event. Um, by far, the primary coding agent of coders today, according to our surveys, is Claude Code, and it's not even close. In July, we saw this slight tick towards Codex, but the tick looks like this, like down at 20% was Codex, up at 80, at what 75% or something was Claude Code, with the other ones with tiny shares of the market. And in July, we saw this little tick where they got slightly closer, but Claude Code is still absolutely dominating. The one kind of interesting factor there is that while when you ask the question primary, software developers are you will use other harnesses and other models as well. And I think that's where Codex was fitting in for a long time, is as the adversarial review, for instance. I think open source models are going to get more and more prevalent as cost comes into it. And, it depends what happens. One of the interesting things, the effects of the open models, is that it's put pressure on Anthropic and OpenAI to keep the price down and to keep the subscriptions rolling for their frontier models. And that's actually had the interesting effect of keeping people on frontier models. Um, but routers getting more and more sophisticated. I think we're about to see a big change in routers. We can certainly see one coming where if you use the context very carefully, you can do a different type of routing that's going to be much more effective. And you'll naturally see a lot of the workload shift to open source models and smaller models for a lot of the software development process. That's going to have a large effect on what people use. But to your point before about um, cost, I think software engineering leaders are still thinking about security and velocity, and that's keeping them by and large for now on the frontier models. I think there's a lot of kind of individual developers, solo developers trying out open code and more of the open models. So we'll eventually see that come to enterprise, but it'll just be a little slower.
So, and I know this is a question that everyone always asks, but I have to ask it. So, and all right, what will happen to traditional SaaS pricing models when software can be built and customized on demand by AI agents instead of bought off the shelf?
Yeah, this is kind of, I feel like the question that's always asked is a question about the black hole. Like, our frontier models, our frontier model company is essentially a black hole that sucks up all of SaaS. Um, and I think that the concept of software for one is really powerful. Like, if you're an individual right now, it's actually economically efficient to build software for yourself, which easily derives the fact that it's very efficient for a software company to build software for themselves, or a non-software company to have a software department that builds software for themselves. I mean, this has been always true. Large companies have. It's just changed the scale at which it's economically efficient. And definitely, even medium-sized companies now should be building software themselves. We're actually betting on it. We're betting those companies need context engineering so they can build sophisticated software by themselves. Um, I don't think it's the death of SaaS. I think there are people who know a lot about specific industries. Their knowledge is embedded in systems. That continual embedding and innovation and outsourcing of innovation to a product company that focuses on it across an industry will continue. And I also think that the power of customer connections and customer service is going to mean that companies like Salesforce will continue.
So, how does the role of a VP of engineering change when they go from managing 50 human developers to managing 5 developers overseeing 100 agents? Or do you think that they'll just keep managing 50 developers and just they'll be way more productive and have way more things to do? What do you think?
I think it's the second one, but maybe not quite the second one. I think what we should see is smaller teams doing more projects, and then it's up to the company's appetite for innovation. Like, if they don't need 50 projects rolling, then maybe they have, 15 teams of 3 and you don't quite have your 50 developers anymore. Maybe you've got 45. Um, I don't think it necessitates headcount reduction. I think that the roles will evolve significantly. I also think there'll be more pressure on software companies to innovate, and that will keep their headcount high. I also think that investors in software companies have an idea about their operating costs right now, and they're going to continue to accept kind of a fixed cost around the headcount um, payroll for the software engineering part of software organizations. So, like, if all software engineering organizations were operating on a level, um, then you all have to adjust to the acceleration and velocity. And I think it's a Jevons paradox argument, right? Like, there's just enough to do out there that acceleration is still going to be valuable, and that's what I believe. I believe there's a huge problem space for software to address. And so, as we get acceleration, it's still going to be economically advantageous to get more acceleration, keep the headcount, and grow the headcount. I think software developers are much more valuable per person now than they were 3 years ago. So you should be able to hire them with that value in mind.
So I just have a couple more questions, probably three or four more questions. And this is just kind of a weird one, but I don't really know how to phrase it reasonably. So, if AI handles the bulk of junior level coding, how do software companies train and hire entry level engineers in the future? Like, what does that look like? How does that go down? Yeah.
Yeah, we've got an idea about what junior level coding is. It's about, you know, somewhat what we've taught in universities. When I went through, it's very different to what they teach now, necessarily. Like, I guess they probably still, do some on machine language and on very
Sorry.
low level languages.
Sorry, but do you mean, sorry to interrupt, but do you think that it means like now that they have these tools, these factories, software factories, right? Like, do you think that they'll have to have a much more robust portfolio of, obviously, you know what I mean? Like, because they're augmented. I don't know. Sorry.
Yeah, maybe let me answer it in a simpler way. Um, the role of junior developers in an organization has always been affected by the fact that you're trying to build senior developers. It might be a little less cost effective for people to hire junior developers. That may have been true for a long time, but we accepted that that was part of the process to grow people into senior engineers. Um, I don't think the ratio of how much less or more kind of economically viable a junior hire is will change very much, because I think the role of a junior developer will change just as the role of a senior developer is changing. I think the junior developers need to be trained on what architectural choices you need to make in a code base, rather than how to go look for the documentation for a particular framework, or for an internal documentation on architectural decisions that have been made. So they're going to end up doing different things, is the short story. And juniors are going to learn things, and they will not be as valuable as senior developers, but the ratio still probably remains fairly similar. So I don't think we need to change the ratio of juniors to seniors in organizations. There's been a lot of argument around that. I don't think that's necessarily true, but I think you need to evolve your software development practices before that's true. Especially once you've built a software factory, there's lots of ways to involve juniors in the process. But while you're just relying on senior taste to review code from Claude Code, it's a pretty hard equation to bring in juniors.
So, what is the biggest opportunity or the biggest fear that you're hearing about from engineering leaders when they speak behind closed doors?
Yeah, I think the biggest fear right now is that they can't keep up with expectations. There's this expectation that they 10x every member of staff with Claude Code, and what they're seeing play out in their organization is not a 10xing. It might be a 40% plus xing, but it's not what people are seeing on greenfield projects. And that's why we exist, because we think we can help software engineering organizations get to that velocity, but they need to do some context engineering configuration work to get there. But that's what we're seeing the warriors for engineering leaders is, CTOs are being told by their board, use AI, either drive down headcount costs or drive up innovation and show us you've done it. And so they have to come with an AI initiative, which is usually followed by some anthropic salesperson saying, hey, by the way, if you want some licenses, here they are. And the leader then says, okay, now we have Claude Code across all of our developers. And if you look at the studies, this is the productivity increase we expect. It's really hard to show that extra velocity. It's hard to show the change in progress and velocity. And it's hard to prove that they're getting the velocity. It's also hard to achieve the velocity in a large organization because of all the process that's already embedded into the software development lifecycle. So I think mostly, VPs of engineering, CTOs are struggling with the expectation gap, and they're struggling with process change. There's some aversion to AI. There's some software engineers who just really love puzzles, and they're just sad to not work on syntax anymore. Like they really like working at the language layer, and they're struggling to get those people over the line. But mostly it's expectation gap with the board and change management.
Well, like you talked about in the last recently, in the last month or even so last several months, we've seen how expectations versus 400% increase in productivity is maybe not close to that, maybe 1/10, and but also there was massive headcount decreases. So where do you think the industry is right now? What unique insights do you think that you have?
Yeah. Well, firstly, I think the headcount decreases were AI was an excuse. Organizations were slimming down because they weren't sure of what path they were going to take. And so it wasn't the right time to put money into an investment. And so they slimmed down their headcount to adjust for that. And AI was the excuse. Oh, we're so much more efficient with AI. So we don't need the headcount. So we're going to slim down. By the way, developers, it's not your fault. It's just that AI has made your peers really efficient. So this is a blameless, uh, you know, headcount reduction and hiring freeze. I think that's the first thing is it was an excuse. Um, but also, I think that there is some wisdom in slimming down before you scale up again, and it's easier to turn the ship when it's a smaller ship. It's easier to do change management when you've got a smaller organization. So in periods where we're about to go through large change, it makes sense to slim down the organization so you can make that change and then hire again. And that's what I expect to happen, is I expect to see huge hiring in 2027.
So what how can your company help CTOs and software companies be more efficient in ways like we talked about how they're not seeing the productivity increases that they wanted? What can you do for them? And can you give a couple examples of how you really affected that?
Yeah. So, you know, our product can be used as a SaaS almost instantly. Any developer in the org can test out our SaaS with a private code base to see efficiencies in token usage and adherence to rules and the visibility they can get. So they can just try it out really simply. But for an organization, one of the great ways that they can work with us is with a pilot, a 6-week pilot. We can either put in the architecture agent, management agent, which gives them full visibility across all of the architectural changes across all of their code bases, which right now is coming at a pace because when you start using Claude Code, the changes, the decisions that are being made just accelerate. And it's really hard to keep track of the organization. So the first thing that you see in that pilot is this complete visibility that's been really difficult because you can't just read PR descriptions anymore. But the next thing that you see is actually guiding governance across the organization, token reductions, and better code. It's easy to see that across 6 weeks. So running a pilot with the architecture agent, by the end of 6 weeks, you're going to see a big change. And right now, we're diving into 6-week pilots with organizations of about 130 developers as one, and there are others in the hundreds. We're talking to a company who's in the thousands. There's one systems integrator who's got 130 concurrent engagements, and they want to bring us in. The other way is that we help people build software factories. So if you're looking to build a software factory right now, we work with the Gas City team. They're working with incredibly large customers, bringing Gas City into organizations with tens of thousands of developers. We can run that pilot. We can boot up a software factory around one large code base where you're struggling to get acceleration and show you what that looks like. And the great thing about the architecture management agent is you get the visibility around that. You can see the change in architecture, the acceleration in progress as you build out the configuration in that factory.
What is something you believe that 90% of the software industry or 90% of developers would disagree with you on, but you think you have a unique insight? What is that?
90%? Oof, that's tricky. Um, I don't know. I believe the good guys will win.
Or like what unique what things do you think that you understand like about something in the developer space that majority of people don't, you know what I mean? Because you're yeah.
Yeah. Um, I think the majority of people are still focusing on what's the best model. And I would say there's a lot more to do with the harness layer. So, Gary Tan talks about thin harness, fat skill. And I would say that we need fat harness, fat skill. That's probably my most controversial opinion.
Do you think that the biggest pain point and the biggest kind of problem that's gotten out of control is the memory and the harness layer? That now like that needs to be what people need to focus on seriously because it's
Well,
handicapping them.
another opinion I have is we need to think about context in multiple ways. Like memory is not the complete solution. You need you need a memory, but a memory is a memory of the decisions that an individual developer makes. And you need to manage your context at an organizational level. It's a completely different thing. So, you need to think about these layers of context that you use to build up your software factory setup, your automated pipeline, or even just like if you're just having Claude Code across your organization, how do you give them the skills and the context layer in each of the code bases to use Claude Code efficiently, which our architecture agent um, is compatible with all of the coding agents and is still very useful even if you're not building a software factory. If you're just using Claude Code or Codex, you still need that context layer. And I think that's one thing that organizations don't invest in enough is thinking about each layer of context and how that all works. Yes, have a memory solution. Yes, do context engineering. Yes, have skills. Put them all together.
How are you able to cut token spend so much with actual AI? How do
Yeah,
you
if
do
you
that?
if you think, I mean, on our demo site, you'll actually see what the agents do, and they go down a big research path. They go down a lot of dead ends, and they have to read a lot of code. And it makes sense because if you gave a developer a code base and they had just had to read the whole thing to understand how to build the next feature, they're going to be spending a long time. If you give them a set of rules and documentation, which is, by the way, what we've always done, like for large code bases, we've always had documentation to go and read for new developers who's kind of looking at this code base. Basically, coding agents today, they have memory, but oftentimes they're looking at a code base with fresh eyes every time. And so if you give them that active documentation that's always accurate because we keep processing every PR, so we understand how to update the ADRs over time. If you give them that accurate, active context and rules around the code base, they can just take a huge shortcut, which is abide by the rules. Like you're about to make an architectural decision, use the rule rather than having to scan the whole code base.
Why aren't more people doing this independently of large organizations? Why do you think? What have they
Tons
missed?
are. Tons are building architecture MDs, tons are using ADRs. We see it all over the place. It's just that the way that we do it is very sophisticated. Like it is the way that works with a large code base. So, we have a batch processing system built on temporal that means we can process millions of lines of code effectively. We can break it up into chunks. We can discover evidence across the whole code base to the point where even if you have conflicting evidence in a code base, we can work out what the decision actually is based on the evidence that we're seeing, and then create a set of rules, deduplicate them, deconflict them, optimize them for agents. All of this takes a long time to build. So absolutely, people are using ADRs in their code base. They're using architecture MDs in their code base. It's just that if you build optimized ones, they work way better and they work for large code bases.
All right, John. So for the last question, take as long as you want, please. So for investors, venture capitalists, potential customers, CTOs, developers, what can you tell them about actual AI? I know it's like a large audience, but obviously take as long as you want. What could you tell them about actual AI? They might misunderstand. They might not understand why they need it. They might not understand. They think they know everything. What would you say to them, please?
Yeah, I would just say you need to take more bets. Like you need to invest in a lot of areas to understand what's going to work for your organization. And one of those bets is context engineering. and we're addressing a very specific part of context engineering thoroughly. We cover the whole gamut of context engineering, but we're really good at software architecture. We know that's the highest point of leverage. So if you haven't tried us out, you should probably try us out. You got to take more bets.